Least common multiple, 3 different ways. Find the LCM for 15 and 50 using multiples method. For that, we're going to write the multiples for 15 and we're going to write multiples for 50. And then we will find least common multiple using the multiples we have received for 15 and 50. So multiples for 15 are I went up to 10. Multiples for 50. Should I keep going? No, I'm seeing something. Notice, we're looking for least common multiple. So in these two numbers, we found the multiples of them. Which multiple, which is common and the least one. So the common and least multiple is 150. So with first method, our LCM is 150 using method 1. Let's go for method 2. Method 2 is prime factorization method. That means we're going to use the prime numbers to do the prime factorization and find the LCM. So we have two numbers, 15 and 50. So we're going to place here 15 and we're going to place here 50. We're going to use prime numbers to do the prime factorization. So we're going to make a list of the primes, 2, 3, 5, 7, 11, 13, 17, 19, and keep going. We're going to start with the smallest prime 2. So let's find out 2 times what number is 15? None. So we're going to go with the next prime. 3 times what number is 15? 5. As soon as you see that in your branches, your last two numbers are prime numbers, you stop there because nothing else can be done there. So the prime factorization for 15 is 3 times 5. Prime factorization for 50. Start with 2. 2 times 25 is 50. 2 times some number cannot be 25. Let's go with 3. 3 times any number 25? No. Go with the next prime 5. 5 times 5, 25. These two are prime numbers again. We stop there. How do we write our prime factorization? You start with your top left corner here and then you go down to your bottom right corner and you write your prime factorization in this direction using those prime numbers. So now 50 prime factorization is 2 times 5 times 5. These are prime numbers. Remember 25 and 50, they're composite numbers. We're going to write this into exponent order. So we're going to write as exponent form. So 2 times 5 to the second power. Now we're going to find the LCM. So what is my LCM? We're going to write all the primes which appears in 15 and 50 only once. And we're going to look for the highest exponent of each prime among them. So we have prime number 2, then we have prime number 3, and we have prime number 5. But we have to look for the highest exponent for each one of them. So the highest exponent for 3 is just 1, so we keep as a 1. 2 is 1, we keep as 1. But 5, as you notice, you have 1 and 2. We cannot go with 1, we have to choose the largest exponent. So that gives you second power. You multiply all of these numbers together and that gives you 2 times 3 times 5 times 5, which is in our case 150. Notice with the second method, our LCM is still 150. Let's do the third method. And the third method is table method. For table method, you make a column and row. So I'm going to make a column. I'm going to make 3 columns because I have 2 numbers, we need 3 columns. If there were 3 numbers, we need 4 columns. So these are my 3 columns and bunch of the rows, right? I'm going to write down my first column. I'm going to keep it, that's for prime numbers. So here I'm going to keep it for prime numbers. My first column. My second column, 15 goes in the second column. And my third, 50 goes into third column. And I'm going to start with the smallest prime. As long as you can use the smallest prime for either one of the column, you have to keep using it. Once you can't use that for either one of the column, then you go with the next prime. So for instance, let's start with 2. 2 times any number gives you 15? No. Bring down 15. 2 times what is 50? 25. Can 2 still works for either one of the column number 15 or 25? No. Let's try the next prime. 3. 3 times 5 is 15. 3 times nothing can be 25, so bring down 25. Can 3 still works? Let's check it. No. My next prime is 5. 5 times 1 is 5. 5 times 5 is 25. Notice, as soon as you hit 1 for either one of the column, you're done with that particular column. So now we only have to worry about this column. Can 5 still works? Yes, it does. So we're going to say 5 times 1 is 5. As you see, we have 1 in both columns, so we're done with the process. My prime factorization is on this side. So this is my LCM. So now my LCM is 2 times 3 times 5 times 5. So it's, if I write this as in an exponent form, it's 2 times 3 times 5 square, which is 150. And notice one of the very cool thing here. Did you notice that this itself is a prime factorization right here? Did you guys notice it? Right here. So this number, let me erase this yellow line. This number is your LCM right here. 2 times 3 times 5 square, 2 times 3 times 5 square. One more important thing I wanted to add up here is, how do you find LCD? So let's say somebody asks you to find LCD. They give you this question, but they're going to rewrite this question as this: 1 over 50, comma 1 over 50. When they give you this question, then they will not say find LCM. They're going to say find LCD. That means least common denominator. Why? Because now these numbers are in the denominator. So you're going to use this number to find, you're going to use these numbers to find the least common denominator. But the process is exactly the same. You can choose either one of your favorite method to answer the question. Now, practice to find the LCM for 20, 24, 45. Let's try that. 20, 24, 45. So find the LCM for 20, 24. Let's check the number double time. 20, 20, 45. So 20, 24, 45. Now, my favorite method is very quick way to go is just use the table method. So I'm going to use the table method. So I'm going to place 20, 24, 45 in a column like this. I'm going to be a little conservative, everybody, because of the space wise. So I'm just going to put 20, 24, 45. I'm going to make my rows width little smaller so we can fit all of them in here. Okay. Let's hope that we're not going to go out of the territory. We're going to start with the smallest prime. Let's make a list of the primes here. 2, 3, 5, 7, 11, 13, 17, 19. I'm going to start with 2. So 2 times what number is 20? 10. 2 times 12. 2 doesn't go into 45. Bring it down. Can 2 still works? Yes. 2 times 5. 2 times 6. Still doesn't work. 5. Can 2 still works? Yes. Bring down 5. 3. Bring down 45. Can 2 still works for either one of the column? No. Let's go with the next prime. 3. 3 times any number 5? No. Bring it down. 3 times 1. We're done with second column. 3 times what? 15. Let's do furthermore. Can 3 still works? Yes, for 15. We're going to keep using it. 5. This one we're done. 3 times 5. Can 3 still works for either one of the column? No. So we're going to go with 5. 5 times 1. 5 times 1. Notice we have 1, 1, 1 for each column. We're done with the process. So what is my LCM for those 3 numbers? Let's write it. So my LCM is 2 times 2 times 2. 2 times 2 times 2 times 3 times 3 times 5. Let's write in exponent form. We get 2 to the third power, 3 to the second power times 5. This is really called a prime factorization, okay everybody? It's a prime factorization format. But now when we want to do LCM, the final answer, it will be 2 to the third power, which is 8. And then 3 to the second power is 9. And then times 5. When you multiply all of them together again, 2 to the third is 8. Times 3 to the second power is 9. Times 5. The easier way to go without calculator is you go 8 times 5 is 40. 40 times 9 is 360. So this is your LCM for 3 numbers using the table method. Hope this will help you.